Converting and running LTSpice circuits in TINA. In this tutorial video, we will demonstrate how to seamlessly convert LTSpice circuits to TINA, DesignSoft's offline circuit simulator. Migrating these schematics into TINA enables you to immediately execute and evaluate them locally on your computer. Note that the generated .tsc files are fully cross-compatible, ensuring a smooth, unified workflow between TINA, the offline desktop application, and the online TINACloud platform. Educational RLC Circuit. TINA includes several ready-to-use sample circuits, which you can find under the Examples, Import, LTSpice folder. Let's start with a simple educational RLC circuit. This is how the circuit looks in LTSpice. Select the RLC circuit. After running the quick conversion process, the complete schematic appears directly inside the TINACloud editor, ready for testing. First, we will run a transient analysis. Go to the Analysis menu and select Transient. As soon as the simulation completes, the resulting time domain waveforms are displayed cleanly on the screen. Using the Collect Curves command from the View menu in the diagram window, you can also plot the input and output waveforms on the same coordinate system. You can also label the curves with their signal names using the Auto Label Curves icon in the diagram window. Configuring AC analysis. Next, let's explore the frequency domain. Navigate to the Analysis menu and select AC Analysis, AC Transfer Characteristic. In addition to standard AC Bode plots, TINA features advanced calculation capabilities, allowing you to easily generate amplitude, phase, Nyquist, and group delay diagrams. Select the AC Bode, amplitude, phase, and Nyquist diagrams, and set the start frequency to 10 kHz and the number of points to 1000 for a high-resolution output. Then click OK to execute the analysis. 4 separate tabs will appear, displaying the amplitude, phase, Nyquist, and amplitude and phase Bode diagrams. Symbolic analysis in TINA and TINACloud. A unique feature of TINA and TINACloud is the ability to derive a circuit's transfer function symbolically, presenting it as an exact mathematical formula. This allows engineers and students to gain deeper insights into circuit behavior, including poles, zeros, gain, and frequency response. This symbolic expression can also be used for analytical studies, documentation, optimization, and verification, moving beyond a sole reliance on numerical simulation results. Note, while symbolic transfer function derivation is only possible for linear circuits, you can still analyze active filters implemented with op-amps. In TINA and TINACloud, non-linear operational amplifier models are automatically replaced with ideal op-amp models during symbolic analysis. This provides highly accurate results, allowing the transfer function to be derived and analyzed symbolically. Running symbolic analysis. Finally, let's take a look at one of TINA's most unique features, symbolic analysis. Go to the Analysis menu, then select Symbolic Analysis AC Transfer and run the analysis. The analytical form of the transfer function will immediately be displayed on your screen. You can easily add this symbolic expression to your schematic for complete circuit documentation. Note that you can also edit the formula within the equation editor by clicking the Settings tab, though we won't cover those features in this tutorial. In the Equation Editor window, click on the Copy icon, or select Edit Copy. Next, in the TINA Schematic Editor window, select Edit, Paste. The formula is now attached to your cursor. Position it wherever you like on the schematic, and left-click to place it. Plotting and comparing results. Beyond formulas, you can also plot the analytical transfer function to compare it directly with your numerical simulation results. In the Equation Editor window, simply click the Calculator icon, then click the green arrow Run icon in the Interpreter window. The plot of the transfer function will appear. To make comparing the analytical and numerical results easier, double-click on the curve and change its color to green. Next, click the curve again, then click the copy icon in the diagram to save it to your clipboard. Now, switch back to the previously calculated Ample1 tab and use the Paste Curve icon to overlay the symbolic result directly onto the numerical curve. As you can see, the two curves match perfectly within the line width. Active Band Pass Filter Circuit. For our next example, we'll look at a similar band pass filter, this time built around the Analog Devices ADA4000-1 operational amplifier. This circuit is a standard building block for what we call active filters. And here is what it looks like in LTSpice. File import and conversion. To bring this circuit into the TINA workspace, open it from the TINA Examples Import LTSpice folder. Or, save the file to your local downloads folder first and then import it using the File Import LTSpice file command. The converted.tsc file appears in the TINA schematic editor. Running AC and symbolic analysis. Since the setup is similar to our previous example, we'll focus just on running the AC and symbolic analyses for this simulation. We'll start with the AC analysis, which generates our combined amplitude and phase Bode plot. Go to the Analysis menu, select AC Analysis, AC Transfer Characteristic, then click OK. The combined amplitude and phase Bode plot appears. Next, run the symbolic AC transfer analysis. Just as we explained in the last video, TINA and TINACloud automatically swap out the nonlinear ADA4000-1 for an ideal op-amp. This substitution makes symbolic analysis possible, allowing TINA to generate the analytical transfer characteristic. Plot visualization. In the equation editor window, simply click the calculator icon, then click the green arrow Run icon in the interpreter window. The amplitude and phase diagrams are displayed. Comparing and overlaying the curves. To easily compare the two methods, first change the color of the analytical amplitude plot to green and copy the curve to your clipboard. Then switch over to the numerically calculated Bode plot tab and paste the green curve directly into the amplitude plot. Repeat this exact same procedure for the phase plot. When you look at the results, you can see that the numerically calculated curves align perfectly with the analytical curves. As we've emphasized in previous videos, this excellent agreement demonstrates exactly why ideal operational amplifiers are so widely used in active filter synthesis. Simulating the LT8640 step-down regulator in TINA. Our final example in this video is a practical evaluation circuit based on the Analog Devices LT8640 step-down regulator. Under its current configuration, this synchronous step-down regulator converts a 24-volt input voltage into a regulated 5-volt output voltage capable of delivering up to 5 amps of output current. Importing the schematic into TINA. To convert and open this circuit in TINA, first save the circuit as an LT8640.asc file in LTSpice to an easily accessible location on your computer. Use the import command to import and convert the LT8640.asc circuit file into TINA. After a brief importing process, the fully mapped schematic will automatically appear in the TINA circuit editor. Important note on the simulation model. The LT8640 model used in this circuit is an equivalent SPICE model, independently developed by DesignSoft, based entirely on the publicly available manufacturer datasheet. Because it follows standard SPICE conventions, this versatile model operates seamlessly not only in TINA and TINACloud, but also in PSpice and other major SPICE simulators. Our independently developed model library is continuously expanding. If you require a specific device model that is not currently included in TINA or TINACloud, please contact DesignSoft. Running Transient Analysis, Average Model versus Switching Model. Now, let's run a transient analysis. Instead of a slow switching model, this simulation uses an average model to ensure exceptionally fast execution times right in your web browser. This approach also provides a major advantage. It allows you to run AC frequency sweeps on the regulator's control loop. Once the libraries load, your results will appear instantly. Select Transient from the Analysis menu and click OK. Once the simulation completes, the waveforms will appear instantly. Customizing the waveform display. To make your simulation data easier to interpret and present, you can easily customize the visual layout of the waveform viewer. Add text labels directly to individual curves to quickly identify voltages and currents. Use the Separate Curves function to isolate different signals and view the results in dedicated stack diagrams. Running AC analysis, Bode plots and loop gain. Because we are utilizing an average model, we can now run an AC analysis to evaluate the stability of the power supply. Execute the AC suite, and TINA will instantly display the Bode diagram of both the power supply output and the circuit's overall loop gain. To present this frequency response clearly and identify your phase and gain margins, simply add distinct labels directly onto the resulting gain and phase curves. This concludes our tutorial on converting LTSpice circuits into TINA. Please note that the same procedure also works in the online version of TINA, TINACloud, and the resulting .tsc files are fully compatible with both TINA and TINACloud. For more information, visit us at tina.com or find us on YouTube at www.youtube@TINA Design Suite.